The ocean has always stood as one of the last truly unknown frontiers on our planet. A vast, shifting world of darkness, pressure, and life forms unlike anything we see on land. Today, let's dive into the story of a deep-sea welder working beneath an oil rig, who came face to face with something he could not explain. Something capable of changing shape, altering its color, and even paralyzing him without ever laying a single tentacle on his body. One person shared a story online about a former deep-sea welder whose background made his account hard to discount. The welder had spent years working hundreds of feet below the surface on oil rigs, pipelines, and offshore structures, often in freezing, pitch-black water with almost no visibility. He specialized in saturation diving, which requires living in pressurized chambers for days or weeks and working at depths where a rapid ascent could be dangerous. Their conversation began casually, as divers often exchange stories about conditions and marine life. It changed when the welder admitted he had encountered something underwater that didn't match any species or behavior he knew. His expertise was considerable. He could identify deep-sea fish by their bioluminescence, recognize sharks by movement alone, and distinguish rare squid species with ease. Despite decades spent in hazardous environments filled with predators, equipment risks, and disorienting darkness, one encounter unsettled him more than anything in his career. It even made him question whether he wanted to continue diving. The incident happened during a multi-day job on an oil rig's underwater structure, a maze of beams and pipes that divers must navigate alone. Communication is limited to radio systems, and visibility is so poor that divers rarely see each other. On this job, even strong lights reached only a few feet. Sediment and murky water distorted shapes and movement constantly. Divers know how easily such conditions can create misinterpretations, but the welder insisted that what approached him on the fifth day wasn't equipment, debris, or any marine creature he recognized. Whatever it was, it forced a seasoned professional to reconsider everything he thought he knew about the deep ocean. Day 5 of a saturation dive usually settles into routine. The first 20 minutes were uneventful, until they weren't. The first sign of trouble was a physical sensation, something heavy pressed against his back. His initial assumption was simple. Another diver must have approached to get his attention, since physical taps are sometimes necessary when communication is limited. But when he turned, no one was there. The radio was silent, and no diver was anywhere in sight. He briefly questioned the sensation. Perhaps a piece of equipment shifted in a current, or an unusual surge pushed against him. Oil rigs often create unpredictable water movement. These were reasonable explanations. His next thought was about marine life. Oil rigs attract dense schools of fish that use the structure for shelter, sometimes moving as coordinated masses that can create surprising pressure when they pass a diver. This too seemed plausible. Then it happened again. This time he turned quickly enough to glimpse whatever had made contact. And in that brief moment he saw something that was shocking. The creature he saw resembled a squid, but the comparison felt insufficient. It shared cephalopod traits, yet combined them in ways that seemed impossible. Its body shifted through forms, stretching into a ribbon-like shape, contracting into a compact mass, then expanding into something entirely different. Its colors shifted just as dramatically. He'd seen octopuses and cuttlefish use camouflage and signaling displays, but this was far more complex. Waves of color pulsed across its body, patterns appearing and vanishing in rapid succession, with occasional flashes of bioluminescence illuminating the surrounding water. The effect was almost hypnotic. Then paralysis struck. He remained fully conscious, aware of the rig structure, his equipment, and the cold water, but none of his voluntary muscles responded. His arms, legs, and even his fingers refused to move. It felt as though the link between his mind and body had been severed. This wasn't nitrogen narcosis, which causes confusion and poor judgment, nor decompression sickness, which develops gradually and causes pain. The only comparison he could make was to cephalopod abilities, chromatophores, color displays, and documented cases of cuttlefish mesmerizing prey, but this creature's capabilities were far beyond known species. No cephalopod, to his knowledge, could immobilize a human without physical contact or venom. No one else witnessed the event. He'd been working behind a massive piece of equipment that blocked visibility, and other divers were positioned around different sections of the structure. The encounter happened entirely within his small pocket of visibility, leaving him the only witness to what unfolded beneath the rig. Enjoyed the video? Don't just stop at the like button. Hit that hype when you watch on your phone too. It only takes a few seconds, but it helps this video reach way more people. And now continue. As the creature approached, its behavior shifted. At 20 or 30 feet, its shape-shifting and color pulses were rapid and intense, but within 10 feet, the changes slowed. As its display diminished, the diver slowly regained movement, first fingers and toes, then limbs, until the paralysis fully lifted. The creature hovered briefly, then drifted away into the darkness with calm, fluid motion. Once it left, a severe headache hit him, followed by intense dizziness that forced him to brace against the structure to avoid losing orientation, always dangerous at depth. Despite the pain, he followed protocol, signaled the surface, and returned to the chamber. He emphasized that before the dive, he'd felt perfectly healthy, had taken no substances, and his equipment had worked flawlessly. He was certain the event wasn't a hallucination or medical issue. Estimating the creature's size was difficult due to magnification and poor visibility, but he was sure it was much larger than he was. After the encounter, he searched extensively through marine biology texts, scientific papers, identification guides, and deep-sea references. He consulted divers and biologists, yet found no known cephalopod with this combination of size, abilities, and behavior. He told no one else, fearing that colleagues or supervisors would assume narcosis, equipment malfunction, or unfitness for duty, accusations that could damage a professional diver's career. After years of working in dangerous environments without fear, he found himself uneasy returning to the water. What unsettled him wasn't the usual risks but the realization that something in the deep had been able to completely overpower his body without ever touching him. Despite centuries of exploration and modern technology, most of Earth's oceans remain unknown. We have mapped distant planets in greater detail than our own seafloor, not due to lack of interest but because ocean exploration is extraordinarily difficult and expensive. Less than 20% of the oceans have been explored. The remaining 80% is largely uncharted, with vast regions never visited by submersibles, cameras, or research vessels. The scale alone is overwhelming. Oceans cover about 71% of the planet, roughly 139 million square miles, far more area than all landmasses combined. Exploring even a fraction of this requires enormous resources. Depth creates even greater challenges. While satellites can map the surface, understanding what lies below requires direct sampling or sonar. The average ocean depth is about 12,100 feet, and many regions plunge far deeper, reaching more than 36,000 feet. These depths create conditions more hostile than space. Sunlight disappears quickly, leaving most of the ocean in total darkness. Pressure increases rapidly, 1 atmosphere every 33 feet, reaching around 370 atmospheres at average depth and over 1,000 atmospheres at the deepest points. These forces can crush equipment not engineered for extreme conditions. Temperatures in the deep ocean hover just above freezing, further complicating exploration and affecting machinery and electronics. Technological advances have expanded our reach. Deep-sea submersibles have revealed hydrothermal vents and ecosystems that thrive without sunlight, transforming our understanding of how life can survive. Remotely operated vehicles can stay at extreme depths for long periods, collecting samples and video. Autonomous underwater vehicles explore without cables, navigating vast regions on pre-programmed routes or using onboard decision-making systems. Even with these tools, most of the ocean remains unstudied. Each new mission brings discoveries, new species, new geological features, and new insights into how the ocean influences climate and supports global ecosystems, while reminding us how much remains unknown beneath the surface. One of the most striking facts in modern exploration is that we've mapped more of the moon's surface than the floors of our own oceans. This seems counterintuitive. The moon is 239,000 miles away, while the ocean is on our planet, but the gap exists because the moon is easier to study with remote instruments than the deep sea. The moon has no atmosphere, no water, and no weather to interfere with observation. Telescopes, satellites, and orbiters can capture detailed images because light and radio waves travel unobstructed through space and reflect cleanly off the lunar surface. The ocean presents the opposite conditions. Water blocks electromagnetic signals extremely well. Light reaches only the upper few hundred feet, and radio waves fail after just a few feet. The tools used to map distant worlds simply don't work underwater. We can't photograph the seafloor from orbit or scan it with radar. To map the ocean floor, we must rely on sonar, sound waves sent from ships that measure depth by timing echoes. This method works, but it's slow and costly. A satellite can image thousands of square miles of the moon in minutes. A sonar-equipped research vessel may take weeks to map a comparable area of seafloor. As a result, only a small portion of the ocean floor has been mapped with high resolution. Most existing maps show broad contours rather than fine features, making it difficult to identify smaller formations or habitats. Detailed mapping is usually limited to coastlines, major shipping lanes, and regions of scientific or economic interest. Meanwhile, vast stretches of deep ocean, especially the remote basins far from land, remain mostly unknown. We have rough bathymetric data indicating general depths, but very little understanding of the true complexity of these underwater landscapes. Reports of unexplained marine creatures are not uncommon. Divers, sailors, and fishermen have long described encounters with organisms that don't match any known species. While skeptics argue misidentification, the number and consistency of such accounts, combined with the fact that most of the ocean remains unexplored, suggests that undiscovered species are entirely possible. Some researchers have even proposed unusual hypotheses about known cephalopods. A few scientific papers have speculated that octopuses might have origins tied to panspermia, noting their unusual biology. Though unproven and controversial, the idea stems from characteristics that set octopuses apart. They display remarkable intelligence, tool use, and problem-solving skills that evolved independently from vertebrates. Their camouflage abilities involve rapid changes in color and texture using specialized skin cells, far beyond the capabilities of most animals. Genetically, octopuses also stand out. Their genome contains unique features and shows extensive RNA editing, rewriting genetic instructions after transcription, a process rare in other animals. These traits led some proponents of panspermia to suggest that octopus genetic material could have arrived from space, though this remains speculative. Regardless of their origins, octopuses are among the most unusual creatures on Earth, and their relatives, squid and cuttlefish, share many of these distinctive traits. Some squids also reach extraordinary sizes. The giant squid, Architeuthis dux, is one of the largest known invertebrates, reaching lengths of up to 43 feet and weights of around 600 pounds. Most of this mass comes from their powerful mantle and long feeding tentacles. Scientists suspect even larger individuals may exist in deep regions, rarely explored. Given the ocean's vastness and the existence of species as extraordinary as modern cephalopods, the idea that divers occasionally encounter undocumented organisms is far from impossible. Giant squids have a mantle, the main body cavity, that can reach about 8 feet in length. This muscular structure streamlines their movement through deep water. Extending from the mantle are 8 arms lined with powerful suction cups surrounded by serrated rings, allowing them to grasp and restrain prey with significant force. They also possess 2 long feeding tentacles, which can extend up to 30 feet. These thinner, more flexible appendages end in club-like structures covered with additional suction cups. Giant squids shoot these tentacles outward to capture prey at a distance, then pull the catch toward their arms and beak. At the center of the arms lies a sharp chitinous beak capable of slicing through prey. Behind it is the radula, a tongue-like organ with tiny teeth that helps process food before digestion. Despite their size, giant squids remain poorly understood. They inhabit depths of roughly 1,000 to 3,000 feet, sometimes deeper, placing them far beyond casual observation. Most knowledge about them comes from carcasses washed ashore or caught in nets, which reveal anatomy but little about behavior, reproduction, or hunting strategies. For decades, observing a live giant squid seemed unattainable. That changed in 2012 when Japanese researcher Tsunemi Kubodera and his team captured the first footage of a giant squid in its natural habitat near the Ogasawara Islands. Using a deep-sea camera and a bioluminescent lure, they recorded the animal investigating the equipment, its skin shifting colors as it moved. The footage showed how these enormous creatures swim with surprising grace, using fins along their mantle to adjust position. Additional sightings have followed. In 2019, researchers filmed a giant squid in the Gulf of Mexico, the first such footage in American waters. Each new observation expands our understanding, but much about these animals remains unknown due to the depths they inhabit and the difficulty of studying them in their natural environment. Scientists continue to discover new marine species at a steady pace, highlighting how little of ocean biodiversity is understood. Estimating the exact number of annual discoveries is difficult because vast regions of the ocean, especially the deep sea, remain unexplored. Expeditions to seamounts, trenches, and hydrothermal vents frequently uncover organisms never documented before, sometimes so distinct that entirely new genera or families must be created to classify them. The World Register of Marine Species reports that roughly 2,000 new marine species are formally described each year. These are species that have undergone the full scientific process of analysis, documentation, and naming. The true number of discoveries is higher, as many specimens sit in research collections awaiting formal description, a process that can take years due to limited taxonomic expertise and resources. The yearly total varies based on factors such as research funding, the number of active taxonomists, and the productivity of expeditions. Some years bring hundreds of new species from a single survey, while others yield fewer significant findings. Describing a species is only the beginning. Once identified, researchers must determine its ecological role, its diet, predators, reproductive strategy, behaviors, and interactions within its environment. Understanding these relationships requires long-term study. Because so much of the ocean remains unknown, countless species likely exist without having been observed. Many may vanish before ever being documented. Continued exploration, research, and conservation are essential for uncovering these organisms and understanding the ecosystems they inhabit. Scientists have identified several reasons why mapping the oceans remains so challenging. The average depth of about 3,800 meters hides extreme variations. While some areas are shallow, trenches like the Mariana Trench reach nearly 11,000 meters. At such depths, pressure is immense, requiring equipment engineered to withstand forces that would crush ordinary materials. Cameras, electronics, and mechanical systems must be sealed, reinforced, and tested for conditions far more extreme than those on land. The oceans cover more than 70% of Earth, over 139 million square miles, making comprehensive mapping a massive undertaking. Even with unlimited funding, surveying this vast area in detail would take decades. Only a small portion of the seafloor has been mapped with high resolution comparable to land surfaces. Mapping relies mainly on sonar, which sends sound waves downward and measures their return time. While effective, sonar requires ships to be close to the area being mapped. Research vessels must travel slowly in overlapping lines, a process known as mowing the lawn, to create detailed maps. This is costly. Ship time, fuel, equipment maintenance, and crew salaries make extended surveys difficult to sustain. As a result, high-resolution mapping is usually limited to regions of scientific or economic importance. Environmental conditions further complicate exploration. Weather can halt surveys, damage equipment, or make instrument deployment dangerous. Strong currents can push ships or disrupt underwater vehicles. Variations in temperature, salinity, and sediment affect sonar accuracy. Even calm conditions require constant adjustments. Unlike land, the seafloor is inaccessible to direct human observation. Researchers cannot simply walk or fly over most areas. Every measurement requires specialized tools, careful planning, and significant resources, which is why so much of the ocean remains unmapped and poorly understood. Estimating the total number of ocean species is extremely difficult because most of the ocean remains unexplored. About 250,000 marine species have been formally described, but researchers estimate there may be between 500,000 and 10 million more, especially in deep sea and microbial communities. Species range from microscopic plankton that form the base of marine food webs to the largest animals on Earth, such as blue whales. Marine life occupies environments from sunlit coral reefs to dark trenches where organisms rely on chemosynthesis. Marine biodiversity includes remarkable adaptations, bioluminescence used for hunting, communication, or defense, advanced camouflage seen in cephalopods and species like leafy sea dragons and stonefish, and extreme temperature tolerance, from Antarctic icefish with antifreeze proteins to Pompeii worms surviving near hydrothermal vents. The oceans also regulate Earth's climate. They absorb large amounts of atmospheric carbon dioxide, storing it through biological and chemical processes. Currents distribute heat globally, stabilizing temperatures. Events like El Niño and La Niña influence rainfall, storms, and weather patterns worldwide. Human societies rely heavily on the ocean. Fish provide major protein sources for millions of people, and global catches reach around 90 million tons annually. Oceans support livelihoods in fishing, shipping, which carries about 90% of global trade, tourism, research, biotechnology, and offshore energy. Phytoplankton produce over half of Earth's oxygen and sustain marine food webs. Despite their importance, oceans face significant threats: overfishing, plastic and chemical pollution, habitat loss, and climate-driven changes such as warming, acidification, and declining oxygen levels. Coral reefs are bleaching, species are shifting ranges, and ecosystems are destabilizing. Protecting ocean biodiversity is essential. Marine protected areas, sustainable fishing practices, pollution reduction, and efforts to limit greenhouse gas emissions all play critical roles in preserving ocean health for future generations. So, what do you make of the mysterious squid story? Perhaps most intriguing is the fact that this diver's account echoes other reports from around the world. Stories from fishermen, divers and sailors who've encountered unexplainable creatures in the ocean depths. While individual accounts can always be questioned, the pattern of similar reports from credible witnesses across different times and locations suggests that the ocean holds surprises we've yet to document and understand. Be sure to leave your questions and answers in the comments section below. Share your theories about what this creature might have been. Have you heard similar stories from other divers or sailors? Do you think large undiscovered species are lurking in the ocean depths? Help us grow this community while working to solve these unexplained mysteries together. Don't forget to hit the bell, share it with your friends, and subscribe if you haven't already. And if you want to learn more about underwater discoveries, check out my videos about strange fisherman catches, where creatures that defy your understanding are revealed. Click on the tab that appears on your screen now. Enjoy. Thanks for being with us. Leave a comment, like to show your support, and remember to hit that subscribe button for more exciting videos. See you next time.